Okay, this is the distributive property and foiling of radicals. You're never going to get away from this. The examples are on page 623, and I have two examples up here for the distributive property. Just like the distributive property when we were distributing in solving systems or in solving equations, okay? The square root of 5 is my distributor. He is going to get multiplied by everything inside the parentheses. So 2 times the square root of 5 becomes 2 times the square root of 5, plus the square root of 5 times the square root of 10 becomes the square root of 5 times 10, which is the square root of 50. So once I've done that, I need to ask myself, are those in simplest form? Well, 2 times the square root of 5 is because 5 is prime. 50 is not prime. 50's factors. 2 times 25, 5 times 10. Bingo, that should be glaring at you. So we get 2 times the square root of 5 plus the square root of 25 is 5. 5 times the square root of 2. Now, are those like terms? No, they are not. So this becomes my final answer. Looking at this one, the square root of 2x is my distributor. The square root of 2x times 6x becomes the square root of 12x squared plus, minus 11 times the square root of 2x. Okay, can we simplify any of this? Well, we have an x squared, so I know I can pull that out, and 12 can become 4 times 3, right? Square root of 4 is 2, so 2x times the square root of 3 minus 11 times the square root of 2x. Can any of that be simplified? No, so this becomes my final answer. Okay, lastly, let's look at foiling. Just like when we foiled polynomials, okay, we're going to have the binomial 2 times the square root of 6 plus 3 times the square root of 3. And our other binomial is going to be the square root of 6 minus 5 times the square root of 3. Okay, I'm going to do this one with a lot of steps first. Okay, so 2 times the square root of 6, the first one's times the square root of 6. So that becomes 2 times the square root of 36. Okay, outside, 2 times the square root of 6 times 5 times negative 5 times the square root of 3. So 2 times negative 5, negative 10, square root, 6 times 3, 18. Inside, 3 times the square root of 3 and the square root of 6. So plus 3 times the square root of 18. And then 3 times the square root of 3 times negative 5 times the square root of 3 becomes negative 15 times the square root of 9. Okay. Now, let's go through and simplify our perfect squares. Square root of 36 is 6. 2 times 6 is 12. That simplifies to 12. Minus 10 times the square root of 18 plus 3 times the square root of 18 minus 15. Square root of 9 is 3. 15 times 3 is 45. Okay? All right, now we've simplified that. Now let's simplify our like terms. Negative 10 times the square root of 18 plus 3 times the square root of 18. So I'm going to move this over here. So 12, negative 10 plus 3 is negative 7 times the square root of 18 minus 45. Okay. Square root of 18, 3 times the square root of 2, 7 times 3 is 21. So minus 21 times the square root of 2, 12 minus 45. Okay, this guy right here is a guy by himself. 12 minus 45. Are those like terms? Absolutely. So what is 12 minus 45? Negative 33 minus 21 times the square root of 2. Okay? That is then our final answer. I want you to do this one. I'm going to go ahead. We're going to talk about conjugates in another video. The square root of 7 plus 4 squared. Okay, what does that mean? Well, that means the square root of 7 plus 4 times the square root of 7 plus 4. You go through and find the result of that and show me before moving on to your guided practice.